Today we will be doing a problem. This problem has two parts. In the first part, it is given that you have a spring whose figure is shown below. We are asked what are the stresses that are acting on the spring due to the axial force F to prove the formula for the stress. So first of all, let's see what kind of stresses will be there in the spring. If we move this force over to this point, then we will have to represent it with this, means along with the force we will have to write the torque as well. And due to this F, we will have a direct shear stress produced in the spring, and due to this torque we will have torsion in the spring. So there will be two type of stresses in the spring. One will be direct stress and other one will be torsion stress. And as the direct stress is given by F by A, and A is given to be pi r square, instead of r, if you put wire diameter d, then A will be equal to pi d square divided by 4. So putting this in the formula, it will give you 4f divided by pi d square. And torsion shear stress is equal to torque T into r divided by J. Here J is polar moment of inertia, r is the wire radius, and T is the torque. And as torque is equal to F into d divided by 2, since F is acting over here and this is the radius of the spring, mean coil radius, and you know that torque is the distance from here up to the point where the force is acting. So this is r, and if you divide mean coil diameter by 2, it will give you this r. As torque is equal to F into r, so instead of r you can put the mean coil diameter divided by 2. And J is polar moment of inertia, so it is equal to pi d to the power 4 divided by 32. So putting these values, it will give you 8fd divided by pi d cube. As total stress produced in this spring is equal to the direct shear stress, that is 4f divided by pi d square, plus the torsional shear stress, which is 8f into mean coil diameter divided by pi d cube. If you take 8f into mean coil diameter divided by pi d cube, from this it will give you this equation. As mean coil diameter divided by wire diameter is equal to C, so 1 over C will be equal to wire diameter divided by mean coil diameter. So instead of this, you can write 1 over C. So you will have to write C over here, and if you take LCM, it will give you 2C plus 1 divided by 2C. So you will get this equation. Now instead of this, you can write Ks as well. If you see over here, this total stress is based on a straight wire, when the wire that is coiled to make a spring is straight. But if it is not straight, since it is coil like, so you will have to add the curvature effect as well, and that curvature effect can be added by Brewster factor, means you will have to write Kb instead of Ks, or you can write Walls factor instead of Ks. So when you put Kb or Kw instead of Ks, it will give you total stress such that it includes the curvature effect also. So total stress will be equal to Kb into F into mean coil diameter divided by pi d cube, or it can also be equal to Kw into F d divided by pi d cube. If you want to find out the curvature effect, you can find it out by dividing this Kb with Ks, or by dividing Kw, which is Walls factor, by Ks. It will give you the curvature effect, and it is represented by Kc. So this is that stress that was required over here. Now let's move on to the next part, in which we are given that we have a helical compression spring that is made up of all tempered wire, and the wire diameter is 4 mm, and the value of C is 10. The spring operates inside a hole, and because of that there will be no buckling in the spring. The free length of the spring is 80 mm, and the force exerted on the spring is 50 Newton, due to which it is deflected by an amount of 15 mm. Now we are required to find out the spring rate K, and we are also required to find out the minimum hole diameter, which will be equal to the spring external diameter. And after that we will have to find out the total number of coils in the spring, and we will have to find out the solid length. After that we will have to find out whether the spring will be safe if we bring it to solid length, means we will have to find out the solid factor of safety. So first of all, let's find out the spring rate K, which is equal to F by Y. Here it is given that F is 50 and Y is 15. So when you put these values, it will give you 3.3 Newton per millimeter. After that, let's find out the minimum hole dia. So for that, first of all, let's find out the external diameter of the spring. External diameter of the spring is equal to mean coil diameter plus wire diameter, and mean coil diameter is equal to C into wire diameter. Here C is 10 and wire diameter is 4, so when you multiply 4 with 10, it will give you 40 millimeter. Now put this value over here, and this wire diameter is 4, so external diameter of the spring will be equal to 44 millimeter, and that will be equal to the minimum hole dia. After that, we will have to find out the total number of active coils, and for that we will have to use this table. And if you see over here in this problem, we are given that the ends of the spring can be plain, so we will have to use this column. So in total will be equal to Na, and Na is equal to 3 to the power 4g divided by 8 into mean coil diameter cube into K. So you know the value of wire diameter, mean coil diameter and K. You don't know the value of this G, so for that we will use this table. Here if you see, for oil and tempered wire, the value of G is 77.2 gigapascal. So put all the values. First of all, let's cut out the units. This is millimeter, it will be cut with this millimeter, so it will give you millimeter square, and this millimeter square will be cutted with this, so in total you will get millimeter square over here. And as you know that Pascal is equal to Newton per meter square, so this Newton and this will cut with each other. Now what you will have to do is to convert this millimeter square into meter square, as 1 meter is equal to 1 meter is equal to 10 raised to the power 3 millimeter. So dividing it over here, 10 raised to the power minus 3 meter will be equal to 1 millimeter. So 1 millimeter is equal to 10 raised to the power minus 3 meter, and when you square it, it will give you 10 raised to the power minus 6 meter square. So instead of this millimeter square, we can put 10 raised to the power minus 6 meter square. So this meter square and this meter square will get cancel out each other, and it will give you 11.7 tons. Now after that we can find out the LS value as well. It is equal to D into NT plus 1. D is 4 and NT is 11.7. So LS is equal to 50.8 millimeter. Then after that we will have to find out solid factor of safety, and it is equal to SSY divided by tau S. SSY is actually equal to 0.45 of SUT, and SUT is equal to A divided by D to the power m. A and m value can be found from this table, that is 10.4. If you see over here, for this oil tempered wire, m is 0.187 and A is 1855. So putting these values, that will give you 1431.4 megapascal. So put this value over here, it is going to give you 644.13 megapascal. Now after that you will have to find out tau S, and tau S is equal to Kb into 8fs mean coil diameter divided by pi d cube. So let's find out the Kb from this formula. C is 10, so 4 multiplied by 10 plus 2 divided by 4 multiplied by 10 minus 3 will give you 42 by 37. And Fs can be found from this equation, that is Fs is equal to K into Ys. Ys can be found from this equation, which is equal to free length minus solid length, and free length is given to be 80, while solid length is we calculated to be 50.8, so it will give you 29.2, and when you multiply K over here with this, that is 3.3, that will give you 96.36 Newton. So put all values over here. Fs is 96.36 Newton. Mean coil diameter is 40 millimeter. Wire diameter is 4 millimeter. So now cancel out this millimeter with this one. So in the denominator we will get millimeter square. And as millimeter square is equal to 10 raised to the power minus 6 meter square. So instead of this we can write 10 raised to the power minus 6 meter square. When it go to the denominator it will become 10 raised to the power 6. And now this Newton divided by meter square can be written as Pascal, and this 10 raised to the power 6 can be written as mega. So here we will write. Now after the calculation it will give you 174.09 megapascal. So put this 174.099 megapascal over here, and this SSY, that is 644.13 megapascal. So 644.13 divided by 174.09 will give you 3.7. That's mean that you are solid safe.